All right. So we've talked about independent tasks in the beginning. Okay. Independent tasks are just tasks that have nothing that comes before them. So when we drew your project diagrams, the ones that came directly from the start, those would have been independent tasks. Nothing has to be done before these tasks can be done. So what does the project diagram look like if we have independent tasks? So they're telling us we have tasks A, B, C, D. Task A takes 5 minutes, B takes 2, C takes 3, and D takes 7. So if they're independent, they all come from the start. So task A that takes 5 minutes comes from the start. Task B that takes 2 minutes. Task C that takes 3 minutes. And task D that takes 7 minutes. So all of these can be started at any time we want because they have no prerequisites. So the only arrows, again, that lead into independent tasks are the arrows that come from a start. If every task is independent, that means none of them lead into anything else either, which means they all lead to the end as well.
What's that noise? You hear that noise?
The AC?
No, like,
that's what it is.
Right there. You hear the squeaking noise.
The AC.
It's the AC.
It's the AC?
Yeah.
Hold on. He said Andy Castro.
It's the Andy Castro.
AC.
Okay, so what we're going to do is we're going to figure out the fastest way to schedule independent tasks. So we're going to actually draw them on a timeline, which is what these all are. So the first one we're going to do, we're going to schedule both tasks for 2 processors. I need to rewrite all my times down here so we have them. So A was 5, B was 2,
3,
C was 3, and D was 7. Okay, so we want to figure out how 2 people can do these processors in the fastest amount of time. Okay, so first off, we need to find the total time. If you were one person doing all of these tasks, how long would it take? 17 minutes.
Dang.
Okay, if you add all these up, 5 plus 2 plus 3 plus 7 gives me 17. It would take one person 17 minutes to do these tasks. What if I split the work between 2 then?
What you divide or something?
Okay, we're going to split between 2.
5.
So we're going to divide by 2. Okay. The only thing is, you can't work 8.5. You have to work whole numbers. You cannot split any of these tasks. So we have to go with 9. Our tasks cannot be scheduled in any less than 9 minutes. So processor 1's going to do 2 things. Processor 2 is going to do 2 things. What 2 things would you like to give processor 1? 5 and 3. Okay, that gives me 8. 5 and 3. So A takes 5. So you put A and you go out to the 5 and you will draw a line. That tells me that we work on A up till 5 minutes. You then said I compare A with C. So after A, we're now going to C takes 3 minutes. When is processor 1 going to be completely finished?
9.
What?
8.
5 plus 3.
That's 8, my dude.
8, my dude.
Come on.
I did 6.
Okay.
Well,
So,
I'm sorry.
You stopped at 5, and task C takes 3. So 5, 6, 7, 8.
Also, just like that one unit we did.
What one?
We had to put the lines and stuff.
I don't know what Unity's
I forgot
from.
what unit that was.
Shut it up, let them find it.
Oh, he's talking about after.
Yeah,
Oh,
the Skittles
chapter
and stuff.
3.
And the Skittles and stuff on it.
Kind of. Okay, so if processor 1's gonna work on A and C, that means processor 2 is gonna do B, and that only takes 2 minutes. Nine.
So playing 2 wins.
Okay. Why? Because they work the longest?
No, because it was 9.
Not technically. Hold on. Hold on. We're not trying to find a winner.
Oh.
Okay. So
R.I.P.
processor 2 works for 9. Processor 1 only works for 8. Well, guess what? Nobody can go home until everything is finished. So processor 1 is stuck there until 9. But what they do for that last hour is they sit around and twiddle their thumbs. Is that somebody at the door?
Somebody at the door.
Okay. So because nobody can leave until everybody is finished, they're gonna sit there and on their butt and play on their phone and ignore life. Okay. So technically processor 1 wins. They only have to work 8 hours and then they get to play on their phone while the other person's finishing what they're doing. Okay. Huh? What?
Time out.
Why are we timing out?
No. Time out.
I did that in 8th grade.
Okay. If I schedule this between 3 people, again, I still have a total time of 17. And this time I'm going to split the work between 3. So how long should each person work then?
About
6.
6.
Okay, this is going to be like 5.7 or something, which rounds to 6. Because it's like 5.666, isn't it? Yeah. So 5.7. Again, you can't do a fraction. Okay, now, this is supposed to be 6. There is a problem though. Take a look at all of your tasks.
You don't have any.
D takes 7. So, even though our optimal time is 6,
Dictator.
it cannot be any lower than your biggest task. So, this should be 6, but it's going to take at least 7. Okay? Again, you may get a number, but that number doesn't necessarily always work. You have to go by your biggest task. So if the number that you get when you divide is lower than your biggest task, you have to go by that number. So everybody should work no more than 7 minutes if possible. So what would you like processor 1 to work on? D. Okay, it's 7 minutes of flat out. What would you like processor 2 to work on?
Hey.
A. That takes me out to 5. What would you like processor 3 to work on? B and C. That works. So B takes 2 minutes. C takes 3, so that takes me to a total of 5. You've scheduled everything now. But again, everybody is stuck there until every person has finished. Well, processor 1 doesn't finish till 7. So that means processor 2 is going to do nothing for 2 hours. And processor 3 is also going to do nothing for 2 hours. Living the dream. Oh, don't worry. Last class they scheduled processor 1 did D, processor 2 did A and B together, and processor 3 just did C. So they sat around for 4 hours and did nothing. I want that job. Okay. Okay, now watch what I show you. Okay, because you're not going to get problems where you have to schedule it and do this. They're going to give you a question, and then they're going to ask you for an answer of idle time. Okay, so if I have 3 processors, okay, 3 people, and each of them work 7 hours, how many total hours is that?
55.
Huh? 21. I'm like, did he really just say 55? Like, okay, so if I have 3 people and they each work 7 hours, you told me that's 21 hours that they work.
Right.
Well, it should only take them 17. That's my total. So they've got 4 hours of idle time. Notice I blocked off 2 hours here and 2 hours here.
So it's
So that was 4.
It's total of 4 hours between everybody?
Yep.
Okay.
Total idle. So I can even come back up here to this one. Okay. I have 2 processors and they each worked 9. So 2 times 9 gives me 18. They worked a total of 18 hours. Well, it only takes 17 hours to do all the tasks. So I should have 1 hour of idle time. That's there. Okay, so you can find your idle time without actually drawing your picture. Okay, last one, C. 4 processors. I have 17 hours. That means each processor should work
4 hours.
4.25 hours.
Where'd you get the? Oh wait, never mind. Yeah, 3.
All right. So, can they work 4.25? No. What does that round to? 5. Can they work 5? No.
They're gonna work 7.
Your biggest number down here is 7. So if this comes out to be lower than your biggest number here, it has to be this biggest number. So we're looking at 7 hours again. So before we even schedule this, let's see how much idle time we should have. So I've got 4 processors that should each work 7 hours. So 4 processors and 7 hours, which means they're each total going to work what?
28.
28. Minus the 17 that it would take to do it for one person, we should have 11 hours of idle time by the time we're finished. Let's see if we do it properly then. So, what task would you like to give processor 1? A. Processor 2? B. Processor 3? C. And processor 4?
7.
D. 7. Okay. Again, everybody's stuck at work until that last person's finished. So, that means processor 1 has 2 hours of idle time. They idle between 5 and 7. This one idles between 2 and 7. So that's 5 hours. This one idles between 3 and 7. That's 4 hours. This one idles between nothing. They stopped at 7 hours. Well, what do you get when you take 2 plus 5 plus 4? 11. You have your 11 hours of idle time.
That's legit.
Too legit to quit? No, question.
Let me know when you see the YouTube channel.
So what's the answer? Like
You mean what's the answer?
The whole chart?
Yeah, like what?
The chart that you have is your answer. All I'm looking for is the chart.
Do we have to draw the chart? Or did it be done already?
I will give you like this blank
Yeah.
piece. All you have to do is fill in the information.
I ain't good with it.
No, you will never have to draw those
No,
because you don't have a ruler. I got a whole cup full over there.
it's a wash.
Right.
Okay. I've got some new tasks for you. What's the total time for all of these tasks?
24.
24.
24.
Okay. This time I'm splitting between 2. So each person should work 12. Our goal is 12. What can I pair together to give me 12?
6, 4, 2, 7, 5.
6, 4, and 2. So That means I'm doing H for 6, E for 4, which takes me to 10, and G for 2, which takes me to 12.
So I got a question.
Yes.
How do you know what, which ones to put in the, why did you choose HCT?
Because our goal is to reach 12. So you want to come up here and say, what numbers can I add together to give me 12?
And do you have to use
But
all
on
of them?
the, last one we did, we just used, I'm so.
Do we gotta use all of the things given to us?
All of your tasks have to be scheduled,
Okay.
okay?
So if even though, if there's one, like one processor, and you have like 5 tasks, you gotta use all 5 tasks for that one?
For the one processor, no, split them up between them all.
Be like that.
No, but it's like, let's say they ask you for one processor,
I give
and you
you
have 5 tasks, would you use?
If you only have one processor, that processor has to do all 5 tasks.
And then like.
Absolutely.
Yeah, okay.
If I have 4 processors, you can split it up between 4. If you have 17 processors, you can.
Like one would, like 3 of them would have one and one of them would have 2.
So, I think I figured out what I'm trying to ask. So for B, right? We
Okay,
was trying to get, what was we trying to get?
we were trying to get, oh, I erased it. We were trying to get 7.
And then D gave you 7. But why did you only do A and not do A and?
You could have done A and B. You could have switched this up, and you could have done A to here, and then put B here, and then put C down here, and then C would have just idled for 4 hours instead of splitting up the idle time.
Could we not have done D and another thing?
You couldn't do D in another thing though, because your goal was 7. If you add anything to D, it's gonna go above 7. You want to try to not go above 7.
Oh, yeah, so it can't go above.
So if you can't get, so you did D, okay? You could have paired up anything to reach 7 or get as close to 7 as possible, but you never want to go over. So, like I said, you could have paired these 2 together and scheduled them together and put this one with the last one. Or if you wanted to make it a little more even, like we did, you schedule A and then you put B and C together. That way one person's not just sitting there twiddling their thumbs and getting paid for it. Okay.
I get paid.
So we did H, E, and G, and that took us to exactly 12. And then we have what left? F, that takes me to 5. And I, that takes me to 12 then. Okay, so we have no idle time. That's okay. You're not always going to have idle time. If there is no idle time, that means 12 was the optimal time. Because there is nobody sitting there doing nothing. Everybody's working the full set of hours. Okay? So it is the most optimal time if you work straight through with no breaks. Okay? 3 processors. Again, we start with 24 hours. Split in 3, which means every person should work
8.
8. Okay? We need to divide these up between 3 people.
G and H.
G and H. Okay? G is 2. H is 6, which takes me to 8. So we've scheduled G and H. I already know. I'm waiting for somebody to just say it.
Oh, you can't do it.
Yeah, you can't, you're gonna go over 8.
You're gonna go over 8. Okay? So 8 is technically our goal, but if we have to go over it because there's no way to avoid it, it has to happen.
So it's overtime.
So when you put E and F together, that gives you a total of 9. Okay, so E and F can be scheduled together. That's okay. And then I get scheduled by itself. The thing with this time is you never ever want to go less than that.
So would you still mark the other stuff as idle time?
Okay, we're still gonna mark idle time. So processor 2 doesn't finish until 9, which means processor 1 idles for an hour. Processor 3 idles for 2. So that's a total of 3 hours of idle time. Again, if I have 3 processors and they're each scheduled for a 9-hour shift, that's 27 hours. Well, it should have only taken 24 hours to do, which means I should have 3 hours of idle time. Because when you cut off this, it had to go to 9 because you had to pair E and F together.
So we can't do the equation before we break it down.
Not always. You're probably going to see a question on your test that says you have 4 processors and each work 5 hours. So 4 and 5 give you 20. If it only takes 17 hours to do your tasks, how much idle time do you have? 20 minus 17 gives you 3.
Bro, it feels like 2:30.
It just passed 2:30.
For real.
Yeah. It's
So it's like-
2:32.
I'm crazy.
So, I mean, I guess it's a good thing. 'Cause it is.
Yeah, I guess your internal clock is on.
Right. Okay, actually, let's skip this one because I think you've gotten the point. Okay. Let's go to this big one.
Oh, no, you got that.
Oh, yeah. Oh, yeah. Which is why I said you need your calculators today.
So I told you, I like the
Okay. I need total time for all of these tasks. How long should all of these tasks take?
Oh, no, hold on. You gotta get the time.
540. 540.
If you add all these up, you get 540. What am I dividing this by?
35.
3.
3. I'm splitting the work between 3 people. So each person should work
180.
180 hours or minutes or whatever the heck this is in. Oh, it says minutes.
Yeah.
I don't care if you call it hours. I get the concept. I do it all the time.
She said years.
Okay, so 180. What can I pair together to give me 180?
You can.
180. Oh, C and E.
C and E. So C takes 100 minutes. E comes after that, and that takes me to 180. That.
BDF.
I can see how this would come in handy if you're running a business, of some sort, like a factory business.
BDF.
Where you have to make.
You said what?
BDF. Or
B-
BHI.
What?
Bro, what are you? Oh,
E,
he's not wrong.
BHI
BHI
gives you
works.
exactly. I said first. BDF.
You said what?
BDF.
B, D,
That also
F.
works.
Oh, yeah.
Okay. That works.
Yeah.
So B takes me to 90. D takes me to 160. And F takes me to 180.
Now y'all.
So what does that leave me for processor 3 then?
A.
GH.
A, G, H, and I.
Yeah. that's
Okay.
fine.
70, 20, 80, and 1, and 10 give me 180. So A is 70. G takes me out to 90. H then takes me out to 170. And I takes me to 180. So while you're marking that, think about the question below it. Is 180 minutes the optimal time?
Yes.
Why?
Because they all end at 180.
They all end at 180 and there is no idle time.
Please.
Okay? Everybody's working the full amount of time.
That's a lot of hours. Working straight.
This one's in minutes.
Oh, okay.
Years. What she say years?
180 minutes is only 3 hours.
Right.
It's not bad.
It's kind of a lot to spend on one thing, unless you're working on something
I mean-
super intricate.
But I mean, this person's working on 2 things. This one's working on 3, so
It'd be like that.
That's true.
Okay, so some of the equations that we just learned. Your finishing time. These are the questions at the bottom of that page. Your finishing time should always be greater than or equal to your total time divided by your number of processors. I just totally spelled that wrong.
What is that? Total time divided by.
Okay. Total time divided by your number of processors. Just like we just did. You added up all the time it took you to take all your tasks, and then we divided by 2, or divided by 3, or divided by 4. All of the numbers that we got, our finishing time was either greater than or equal to that. Okay. Also, your finishing time always has to be greater than or equal to your largest task time.
Oh, wait.
So when we got that total of 6,
No,
but then you went back and told me that D takes 7, and we had to bump it up to that 7. That's what that means. Your finishing time can never be less than the biggest task that you have to complete. So if your biggest task takes 12 hours, your finishing time should never be less than 12 hours.
Not confused by
So is this the hardest chapter we're gonna do this year? Is this a 4?
Depends on how you do with probability.
Wait, for the next unit? Is that what you're saying?
He wants to know if this is the hardest chapter we do. Some kids would say yes, some kids really, really struggle with probability. So it depends on how good you are with probability.
What's probability again? Like, that's what.
Like you have a deck of cards, you pull out a red card, what's your chances of pulling out a red?
Oh, isn't that like crossword cards?
They have answer choices. I guess.
We get into some more detail. It's not quite as easy as you think. Okay. So. These are all the steps that we just got done doing. Okay, this is just a reference for you to go back and look at if you need it. Okay, all of your tasks are ready from the start, so you can schedule anything at any time that you want. Okay, all of your ready tasks, you never idle until everything is finished. Notice all of our idle time is way at the end. Okay, you can calculate your finishing time by adding all your numbers together and dividing by how many processors you have. So we can practice without the charts. Okay, that's what this is. I've got 3 processors, and I want to divide all of these tasks amongst them. So we're going to do the same steps, but this time we're not going to draw out the pretty chart. We're just going to put the tasks together. So how much total time does it take us to do all of these tasks? You said 270? 270 divided by 3. Each processor should work a total of 90 minutes. What can I group together? Give me 90.
A and C.
A and C.
E and G.
Okay? A and C, that's processor 1. I need 3 processors. So what else can I put together? E and G. And B, D, and F. You're done. If they don't give you the chart, this is what I need you to give me.
Why about all of these be like that? You won't have a problem.
Oh, this is gonna get harder.
I know.
Don't say that now.
I'll say that for after spring break.
Right.
Okay, the next one. Somebody do the total time for 2, somebody do the total time for 3, so we can just rock it.
280.
280 for 2?
Yeah.
Split between 2, which means each person needs to work?
140.
140.
I got the next one. No calculator.
I'm so impressed
Oh, wow.
with your no calculator dividing skills. What can I put together to give me 140? This one's kind of hard because you've got the 45, 55. It's not quite as easy to add these ones together and get what you want.
Oh, I'm so close.
Jesus.
B, C, E, and F.
B, C, E, and F.
That's impossible.
E and C,
That's no way.
70, 80.
That's
That's 110. Yeah, that's 145.
Is there
I
a?
said CDF.
You said what?
CDF.
C, D, F.
And 145.
C
Oh, never
and
mind.
D is 100.
Oh, I missed the
You
five.
want to go 140.
Okay.
A, B, C, okay? Hold on. Ashanta's got A, B, C,
Ain't no way.
and what else? G.
Okay.
A, B, C, and G go together.
Mark those out.
So, A, B, C, and G.
I told her that.
What else? So then D, E, and F. Make sure that it adds up to 140.
And if it doesn't, what do we do?
Okay, so let's say for instance that this added up to 140 and you added this up. This is wrong, but this added up to 130. What does that mean?
The idle time is 10.
10 hours of idle time.
Oh, okay.
Okay, so that's all that would mean.
I do.
But these come out to both be 140, so there is no idle time. Finally, number 3.
310.
You missed something.
Yeah, I'm going back to sleep.
Uh-huh.
Thanks. Actually, too.
360.
360.
160.
Okay, this time I'm splitting between 4, so each one should have 90.
Jeez.
B and C.
Well,
So B and C can go together.
I was gonna say we can throw A.
You can start with just A, it's 90 in itself.
F and I.
F
Heck, yeah.
and I,
And then
D, E, H. And then D,
D, E, G, and H. Does that equal 90?
Yeah.
30,
yeah,
90 square on the dot.
get it on my
Okay, so we have no idle time again.
like that.
We're gonna skip number 4 and jump straight into 8.3 now. You only have 2 problems for homework tonight, and it's at the end of this section.
Still got 1, 2, 3.
You can go back and do number 4 if you so well choose.
No, I'd rather not.
Okay.
But I can't.
I'd rather not, but I can. Okay. So now these tasks are no longer independent. We now have a pretty picture that tells me that certain things should happen before certain things. So because I have a line that goes from P to Q, that means P needs to be finished before Q can be started. Okay? P also has to be finished before R can be started. The way we schedule this is we try to make sure every processor is working. Okay? If we can.
But
So-
we have to start out with just one working, right?
Right. Okay, so from the start, I only have one task available, and that is P. So you need to schedule P. And that takes 2 hours.
Are we not gonna, add up all the numbers first?
No,
So it'll be cute.
that's not gonna work here because these are not independent tasks anymore. So, P takes 2 hours. But, like Marcus said, I only have one task that is ready. Nothing else can be done until P is finished. How long does it take P to finish? 2 hours. So that means this person has nothing to do for 2 hours because nothing else can be started until P is done. Okay, so at this 2 hours, we have now finished P. And P leads into Q and R. So now I've got 2 tasks. I've got 2 people not working. I've got 2 tasks to schedule.
Q.
So you're gonna put Q with one of them and R can go here, and that takes me out to 3.
There are on the line.
Are we good here?
Yeah.
Are you sure?
Yeah.
I really, if you get confused, I need you to stop me and we need to talk about it.
So idle time would be.
Okay,
2.
we don't have any idle time yet. So, we stopped here. Which means R is finished. The letter that comes before that line is now finished. When R finishes, T is now ready. So directly after R, I can schedule T.
Oh, no.
So I left off at 3. T is now 5. That takes me to 8.
I thought we would go to 6 because of.
But
What
they
if there are
have
jobs that
2
don't get
hours of
done?
idle time where they didn't do anything. They could not start on R until after those 2 hours. Because
So we have to count.
you
Yeah,
have to count the
and-
idle time. Yes,
What if there's like jobs that don't get?
everything has to be done.
Oh, no.
You cannot finish until everything is done. Okay, hold off for a second. So we stopped at 3. Okay, at 4, everybody's working. At 5, we have another line. This line means Q is now finished. So we cross off Q. Q leads into S. So now I can schedule S because Q is finished. Q ended at 5 plus the 3 hours then takes me to 8.
This is no point.
Right.
I said this chapter is. Dang.
I mean, like, I thought I had it figured.
And then you mark out.
It'll click. Okay, so at 5, now we're at 6, everybody's working. We're at 7, everybody's working. We're at 8,
Nobody's.
we've got some lines. Nobody's working now. Both processors have finished. So task S is now done, which leads to U, and task T is now done, which leads to W and to V.
Oh.
So now I've got 2 processors open and 3 tasks that are ready to be scheduled. It doesn't matter which one you put where. So what would you like to schedule for our 2 processors? I need to pick 2 of the 3 that I have.
Put you at the top,
Okay, you want U at the top. That takes me to 10.
and then put W at the bottom.
W at the bottom. That takes me to 12.
And then I guess what? It just
Okay.
be after.
So then,
After you.
working, we stop here. When U finishes at 10. And now I can put V in. And V takes me out to 13. Have I scheduled every piece of this chart?
Yeah.
Yes. So now 13 is my finishing time,
You got an hour of leave.
and you have an hour of idle. So your finishing time is 13, and you have an hour of idle time.
That was easy.
I think the next section's actually easier when I actually tell you what you need to do than this is. as long as they're ready to go. It doesn't matter where you put them. Okay, take a look at this one. I've got 2 processors. From the start, I have 2 tasks that are ready. So I can schedule 1 for one processor, 1 for the other. So A takes 4 and C takes 5. Once everybody's working, you start looking at the chart. At 1 hour, they're working. At 2 hours, they're working. 3 hours, they're working. 4 hours. Processor 1 has stopped. They're done with A.
Go to B
Yeah, let's do B.
B,
and D.
and it leads to D. Which one is ready? Why is D not ready?
Because it takes 7.
It takes
Oh,
C.
because you need to get C done too.
C also needs to done. You have 2 things that lead into D. Just because one of them is done does not mean that D is ready. C also has to be finished. So the only one that can really be scheduled right now is B. And that takes me to 7. That makes sense? You've got to watch the lines. That's why as I do them, I color the lines in. Whether you want to take a highlighter or a colored pen or something to denote that you have done that. Okay, so now we left off at 4. At 5 hours,
At 5 hours, D
Go to
is,
D.
or C is done. You
processor 2 has finished C. So now
D.
D is ready and E is ready. So you can do D or E at this point.
Do D.
You want to do D. So D. It's 1, 2, 3, 4, 5, 6, 7. That takes me to 12.
Then throw that E.
Okay. At 6, they're still working. At 7, processor 1 has finished with this task. Well, that leads to the end, so that doesn't open anything up.
Right.
We've already scheduled D. E is ready to be scheduled, so it goes here. So what's my finishing time? 12. Don't forget to go back and put this person's idle time in, because they finished with all their tasks at 11, but they have to stay till 12.
Based on chronological order.
Okay. I've got one more screwball to talk about and throw at you.
Priority homework.
Okay. And then you're going to do your 2 problems for homework. Okay. This stuff may make absolutely no sense to you until we actually start scheduling. But I need to fill this in just in case you have something you need to go back and refer to. So now I'm going to give you a priority list. Not only are you going to have that lovely chart that says this has to happen before this and this has to happen before that, I'm going to give you a list of things that need to do. I'm going to tell you that I want you to try to do A before B or B before F. Okay, I'm going to give you a list of what I want. So a priority list is a list of all the tasks prioritized based on the preferred order. Okay. So this is the way that I prefer you to schedule them. Is it going to work? Maybe, maybe not. So your priority lists are going to be listed in order. So like C, A, F, G, okay? If X comes before Y, that means if possible, note the words, if possible, task X needs completed before task Y. Okay. And again, that's an if possible. If you have a prerequisite that has to happen first, you're not going to be able to schedule it that way. So you're going to have 3 options when you look at this. If the task is ready,
Then do it.
then do it. All right? Mikey, just do it.
I take a picture of this and
Okay? If it's ready, just do it. If it's not ready,
Okay.
Then do
Y.
task Y. Okay? If X is not ready, skip over it and do the next available task, which is Y in this case. If everything is not ready,
Then your B.
then we idle. Then you get time to play on your phone. Okay? If there's nothing to be done, you get to play on your phone. Okay. Why do I give you a priority list? Well, if you have 5 tasks, 5 factorial means you have 120 different priority lists that we can do. This is why I give you one. Okay, because heaven forbid you have to schedule all 120 priority lists. No, not gonna happen. Okay? So, your processors, as we schedule, they're either going to be all busy, which means they're working on something. So they're working on a task, or they're idle. And since y'all like your cell phones, we're going to call idle playing on your phone. So you're either working, which means you're busy, or you're idling and wasting time playing on your phone. Do you want to just do it at the end?
Yeah.
And we'll just flip through them and okay. So this is the last wording, and then we're going to do 3 examples, and then I'm done speaking. I promise.
Oh.
Thank God. What a homework is.
Dang,
Don't
that's
take
all
30
time.
No, we're not. I promise. Okay, so there's 3 different scenarios that you're going to look at every time you look at your schedule. Everybody's going to be busy is the first scenario. The second scenario is you've got one person free, so you need to find and complete the first ready task. Just like we did when we looked at the graphs and we said, okay, this one's ready, I can go ahead and schedule it. Okay, so you're going to schedule the first ready task. If you have no task ready, then you're going to idle for new ready tasks. You're going to wait until something opens up. The third scenario, you're going to have more than one processor free. Like at that 8 minutes when both processors opened up, at that point, you're going to assign all ready tasks to all available processors. Again, if nothing is ready, you're going to idle. So, in some more simplified steps that may make more sense when you go back and look at this, step 1, ask yourself what tasks are ready. Identify them in the list. Okay? Schedule your ready tasks and keep going. If you have no tasks ready, we're going to idle. So, here's the first example.
We're still doing full time.
That's only when you're independent tasks. When they don't give you this graph, that's when you do that. Okay, so this is the order that I want you to try to do things in. I want A done first, B done second, C done third, D done fourth, and E done fifth. It's not going to be possible sometimes, but we're going to try. So you go over to your graph. From your start, you have 3 tasks ready. A, B, and C. Okay, because the start leads into them. So they're ready from the beginning. So what I do, and again, if you don't want to use my steps, that's fine, but this is the only way that it ever made sense to me. When I taught myself chapter 8, I taught myself as many cheats as I could. Okay, so the ready tasks, I come over to my priority list and I circle them. Okay, that way when I go to schedule, the only tasks I want to look at are the ones that I have circled because they're the ones that are ready. So You're gonna look at your priority list from left to right. What is the first letter that I have circled?
Hey,
A. So we schedule it. When I schedule it, I cross it off of my priority list. So I know it's already on my chart. I'm done with it. Processor 2 also needs something. It has to be the next circle. So that's B. So I put B here.
You put C right after me.
Hold on.
That's not good.
Okay.
But
So
no,
now
no.
all of my processors have something to work on. So they're working, they're working, they're working, they're working. Processor 2 stops here. What have they finished with?
B.
They have finished with task B. Well, task B leads into D. Is D ready yet?
No.
No, so I can't circle it. Is E ready yet?
No.
No, I can't circle it. So now we go back. This person's done. They get the next circled task, which is what?
C.
C. So C is going to go here. We stopped at 5. C takes us to 7, so we're at 12. Okay, so we stopped at 5. Now we're at 6. I've got another line. Processor 1 has now stopped working. What are they done with?
A.
A. When I come down to D, is D ready yet?
Yes.
Circle it. Is E ready yet?
No.
No. So this person gets my next available circle, which is D. And that finishes at 8.
I feel like we should assign E to P1 then, just because, like, I don't want them to have all that time of doing nothing.
Oh.
You know what I'm saying?
I do the same thing, but you don't have to. So at 7, everybody's working. At 8, processor 1 has finished with D now. Okay. Is task E ready yet?
No.
No. We can't do E until C is finished. Well, what point does C finish?
12.
12. So that means that processor 1 has nothing to do because nothing's ready. Because E can't be done until C is finished. So now at 12 minutes, C has finished, and that leads into E. And E is now ready. Okay, because you have 2 available processors open, you can schedule it to either one. Doesn't matter. Like Marcus said, though, processor 1's been idling for 4 hours. The lazy bums that they are. Okay? So, me, being the cruel person that I am, I would give them that task. I'm not about to give you some more time to sit around and do nothing. Okay? So, I schedule E here. It doesn't matter which one you schedule it at, though. We were at 12 and E takes 5. That takes me to 17. Okay. Have I scheduled all of my tasks?
yes.
Yes. So now, 17 is my finishing time, and this person had nothing to do from 12 to 17. So they get to idle for 5 hours.
Might as well go home. Right.
They can't.
They can't.
Now, what if you would put it at the bottom and just kind of got 17?
Yes. Because what would have happened was you would have put E here, and this still ended at 12. So 12 plus 5 still takes me to 17. It's just this person would have idled for a total of 9 hours.
Okay, because you just say it'd be 17, but then it got 9. You just said 9.
No, it's still.
E still finishes at 17, but when you draw the line here and make them idle back, they've already idled for 4, and now they idle for another 5. So they've idled for 9 hours.
Okay.
It's not your finishing time. Okay, let's take a look at that same graph, but this time I've changed your priority list. Now I want you to try to do E first, D second, C third, B fourth, and A fifth.
Yeah, that's not gonna happen.
It's not. This one's definitely not going to happen. What's available straight from the start?
ABC,
ABC.
so we're gonna start with C.
Right. So now, when you read your priority list, processor 1 gets the first circled task, which is C. That takes me to 7. Processor 2 gets the second circled task,
B.
which is B. That takes me to 5.
And A.
Okay. Working. We stop. When we stop, what is done?
B is done.
B is done. Okay, is D ready yet?
No, so you gotta go to A.
Is E ready yet?
No.
No. So we go to my next circled one. A. So we were at 5, we're adding 6. That takes me to 11. Okay. So at 6, we're working. At 7, processor 1 has finished.
You go to E.
Yeah, you can do
Okay,
it.
so C is done, and that leads to E. Well, you just told me now E is ready, so I circle it. Is D ready yet?
No, not yet.
No. So now, next available circled answer, E. We stopped at 7, add 5, takes me to 12.
Then you can do B on processor.
Okay. We finished with A at 11, which means D is now ready.
Whoa.
So D goes here, and that takes 2 hours, so that takes me to 13. And Natoya says, I'm done. I scheduled all of my tasks, so my finishing time is 13 minutes. And don't forget, processor 1 gets that hour of idle.
That's big time difference.
Okay, so just a matter of the order that I told you to do things in, we just had a 4-hour difference. Okay, so it matters how I tell you to do things. It matters the order that things need to be finished in. Last one. Same chart, different list. So A, B, and C can be done from the start. What gets scheduled first in this list?
A and C.
A at 6, C for 7. The more we practice it, but that's why I said, I'm not taking any homework classes because you need to practice this or else it's done. Okay, so busy, stop. Okay, at 6, I have a line. What's done? A. Is D ready yet?
No.
Is E ready yet?
No.
No. So now we schedule the first one that's circled.
B.
B. That takes me to 11.
Start.
We stop at 7 again. Because C is finished.
You go E.
And that leads to E. So now E is ready. So we circle it. Is D ready yet?
No, not yet.
No, so we don't circle it. Okay, processor 2 needs a task. The first circled one is
E.
E. So E goes here. That takes me to 12. Okay. Working. Stop. It's like the whammy show. No whammy. Stop.
Is that-
Oh my God.
Are you talking about
Okay.
You said wait.
They
You
call
said,
it whammy now.
you said whammy.
Good one's whammy, the old one's.
Oh.
Yeah, I don't know.
I know it's 20.
I'll show you real quick. Okay. So at 11 minutes, what has finished? B is finished.
B is finished.
So B leads into D. Is D ready yet?
Yes.
Yes, I can circle it. So what gets scheduled next?
D.
D.
Hey.
And they finish at 13. Is everything done?
Yes.
So my farthest out line is 13 minutes. Don't forget to go back and give yourself that hour of idle time for processor 2. Are there any questions at this point? Okay.
We should bring back dudes.